mean, I didn't. I wasn't able to make it to class last week. Ended up hurting my shoulder and wasn't able to sit at a computer, so I had to set out. So I kind of figured you.
Well, what I'm going to do is welcome everybody to IoT class. And Derek, what we're going to do today is a couple things. First off, I want everybody to know that I have inside of the connecting things, obviously on your intro to IoT. The only thing you need to do is finish up the class labs that you have due. They're coming due this week, and kind of blow through the rest of it. There's not a whole lot to do in terms of activations. There's no assessments in here, so you don't have to really do a final exam or anything in IoT. And in fact, there's a lot of overlap between IoT, intro to IoT, and IoT connecting things, to the point that Susan and I were talking last week. You will probably in the Net 226 class just use IoT connecting things and IoT security and not bring in the IoT fundamentals, because there is so much overlap between the two. I do have your assignments that I have imported into the IoT class. I have not put dates on it. I will put dates on this so that you're able to at least have a due date. Some of these you'll see, like this blinking LED using a breadboard and Arduino. This, you may not use the breadboard. You may use an Elegoo or any Arduino that you have. I'm going to show you the Arduino today and let you see it. And you know, like this, setting up the pill app with Raspberry Pi, you've already done that. You've already done the pill notebook apps. You've done the basic Linux commands. So some of these you've already done, so don't redo them. You know, blinking an LED using Raspberry Pi and pill app, we did that last week. Don't redo that. And that's really why I'm saying you probably want to use some of these or this class as your starting class for your IoT, especially if you're teaching in Net 226. However, if you have any class that you want to add some IoT to, I strongly recommend you just dump in the intro to IoT, because it's a short little section that you can use. So pretty neat there. There is a final exam in IoT connecting things, because you have to finish it in order to be accredited to teach IoT connecting things. So I will turn that on. Be aware I can only turn it on, I think, for 7 days. I'll check. Actually, let me check right now. This may be one of those I can turn on for longer. If it is, I will do so. Yep, this is one of my long ones. Good. All right, awesome. So I'll go ahead and turn on the final there to the end of August 31st. I know our class ends before that, but I'm actually going to give you all access to these classes past the class end date inside of Neticat. And I'll go ahead and turn on the survey too, because obviously you have to do the survey before you can do the final assessment. So that'll give you that. And I'll do the same for the IoT security when I get you moved into that class. I'll turn those on and you'll have access to them. So be aware, you're going to see some due dates pop up for IoT connecting things. Don't redo any of the labs you've already done. Just got you there. Now I want to show you something really cool I've been playing with, and I have to show you this because I just think it's awesome. But CML Personal Edition, it's called Cisco Modeling Labs 2.0. I've actually rolled it out on a not a NetLab system, but right now I'm running it on an ESXi box, and this is really cool. This is a lab that I built, that I just set up, pulled out the different parts to it and booted it up, and you can see that we have here now when I say a simulated iOS image, it is simulated, but it's the true iOS. So this is basically the GNS that I was talking to y'all about a couple weeks ago, but I showed it to you running on my machine at home. I'm working on getting this running on some NetLabs pods as part of a test that I'm going to do for the fall, which is really cool. But you can see this is just and it's an older version of the iOS v2. So there are some things that are not exactly the same, but I'm just tickled pink to have this running. So I thought that was really cool. Now, another thing I'm trying to figure out how to do, to be quite honest with you, and if any of you know how to do this, hey Tyrone, if any of you know how to do this, I am looking to try to figure out how I can take the Raspberry Pi app that we have for the IoT class and run it inside of a virtual system. Now, I have a virtual Raspberry Pi on one of my systems. In fact, it is, sorry, I keep bumping around here, but I got like 13,000 different things open here. One of these, I actually have a Raspberry Pi that's a virtualized Raspberry Pi, and I'd have to find it, but If we could figure out a way to run that inside of the NetLabs, we could set it up where the PL app was running on a virtualized PC. And if our Raspberry Pi was there virtualized, we could at least do some of the labs without having to connect to the without having them connected locally. And I know that's going to be a big problem in the fall, because right now most of our most of our IT classes are going to be online in the fall. In fact, all of them are going to be online. The only thing we're going to do anything seated would be classes that cannot do anything that's online. So in other words, like welding, heavy equipment operations, and those types of things. And that, of course, still depends on what the governor and what happens in the state. Now, what I want to do is switch gears here, because I want to pull up a different thing. I want to pull up inside of our class, we have, and one of the things I've talked about is this Elegoo kit. And I am going to do a couple things here. First, I'm going to change my camera to my well, said it was. That's a good look for me there. Try to switch my camera. Did I just lock everything up? Are y'all still there? Oh, there we go. Oops. I may have just killed the Zoom session.
Still here.
Okay. Well, oh, here we go. Maybe. Can you hear me, Derek?
Yeah.
Okay. Well, my camera's just doing weird stuff. My camera is locked up. You can still see my screen, or did that stop?
Still got your screen.
Okay. Well, I'm trying to stop the share so I can change cameras to do that. So I got some weird stuff going on with Zoom. Last time I tried to switch cameras, I had the same kind of issues going on, but it eventually cleared up. Can you still hear me, Derek?
Yes, sir.
Okay, I feel like I'm part of a commercial. Can you hear me now? What I'm trying to do is show you the Elmo camera and show you the document camera. Let me turn this thing off for a second. See if maybe I can turn that off. Okay, and hopefully by turning it back on, I'll be able to get the camera to come up. Yep, I got it to come up, but I just have to turn off my virtual background because it obviously doesn't work well on a document camera. Okay, so what you're seeing is my hand, obviously, but what we're going to work with a little bit today, and just some basic things, and Derek, I think you said you already did a lot of it. I'm going to stop my share here so you can see my speaker view. You should be able to see this is the most complete starter kit Uno R3 project. And by the way, it really doesn't matter if you buy this entire kit. The big thing is get you an Arduino. This one is so cheap. I mean, like 60 bucks, around that range. And it is full of stuff. I mean, it has so much stuff in it. Go back to sharing my screen here, and I'll show you just the packing list to give you an idea. So when we look inside of here, this is all the different things. Obviously, you've got the controller, which is right here. So an Uno R3 controller. We've got stepper motors, all the way even down to an RFID module. We've got regular motors, servo motors, excuse me, ultrasonic sensors, LEDs, all these things are in here. A bunch of LEDs, bunch of even some RGB LEDs, which allow you to change different colors based upon the amount of power input into the LED. This kit, however, one of the things I sent out is I asked you to go ahead and download the Arduino software. You can go directly to Arduino. So if you are looking for, just go to Arduino, and if you do, you can go to Arduino Home, and you can see that you can download the software. The current version is 1.8.13. Yeah, I downloaded mine off the Elegoo site, and the Elegoo site was 1.8.12. So I was just lazy and didn't update it, but you could update it if you want to. But here is the Arduino IDE, or development environment. One quick thing to know is that the Arduino sketch languages, or the programs you upload, are a subset of C, C++. So if you're familiar with C++, then you will be very familiar with the code and the way the code looks. I believe this Arduino IDE is written in Java and then passes the code into a compiler that compiles it into C, C++ subset that is used with the Arduinos. Now, the big question I always hear, or I get from people many times, is why, Kelly, do you use an Arduino versus a Raspberry Pi? Well, we're using both, obviously. But one of the main reasons I bought these kits, and again, there's cheaper kits. There's a $39 kit you can get from Freenove. But the reason I went with the Arduino is because I had someone from North Dakota tell me that Arduinos were being used more in the oil and gas industry and in the IoT world. So I wanted to make sure my students understood Arduinos in with Raspberry Pis. Plus, I think Raspberry Pis are pretty common, and people have seen those. They may not have seen an Arduino as much. Now, this, by the way, this part 1, part 2, this is the kit that you download as part of Elegoo. You get a CD in your box with it, but I got to work and figured out I don't have a CD-ROM in my PC anymore, which I forgot. So I just downloaded this off of Elegoo's site. But one of the first things you had to do is just download the Arduino IDE. But I want to show you this board here, because this is some really good look at some of the components all on this board. You'll notice on this diagram here, on this one side, the side closest to the power, so this side over here on our Arduino that we're looking at, actually over here that we're looking at there, the Arduino has a series of digital inputs. So these are our digital inputs over on this top half here. One of the things, if you read this, you'll see if it's got a squiggly. The squigglies mean that let me mute my phone here, folks. That has the ability to have pulse modulation, pulse wave modulation. So it's an analog port that can provide some functionality of it's a digital port that can provide some of the functionality of an analog port through pulse wave modulation. Down here on the bottom, you've got analog ports, 6 ports, 0 through 5. You've got multiple ports that provide either 3.3 or 5 volts in power. And then you also have grounds. You have multiple grounds that are available too if you need to ground things on your Arduino. Power is provided. There's a couple ways to do it. You can do it via USB, which is how I'm doing it. It's also how you upload your programs. And you can actually, once you've uploaded the programs, there's the ability to use just a regular power supply that doesn't require to have USB. Strongly suggest, as I mentioned in class last week, get you a USB adapter or cord, because otherwise you're going to have a really small cord to try to work with here. So I'm going to zoom in just a little bit on that thing, and I'll keep moving it around because I'm going to zoom in just a little more. Actually, I'm getting pretty close on it so that you can see. All right. But you'll see the power LED. Okay. So our power LED, which is it's 11 power indicator down there showing that it's green. We've got a green light on the power. We've got right now the 14, which is our pin D13 indicator LED. It's turned on, but it's not blinking because we haven't uploaded the Hello World Arduino program called Blink. Sometimes if you get these out of the box, it mentions in here that the Blink application will be on from the factory, and that will be blinking. So don't freak out if it is blinking. That doesn't necessarily mean there's a problem with your Arduino. It just means that they've probably loaded the Blink app at your at the factory. So we've got all kind of different things here as far as our different ports. This does a great job defining that, and it's one of the reasons I really like these kits, because they go into detail on Arduino, even much more than what we're doing inside of our class, which is why I think these kits are really a a necessity for these classes. So I've downloaded and installed this. No big deal here. I do want to do something so that you will know. Once you install it, the big thing here is it is going to install a driver so that you can connect a COM port into to connect to your Arduinos. So if you go to Tools, Port, you will need to pick the port. And if it has been installed correctly, the COM port will actually say Arduino Uno, so you will know which COM port it is. So if you plug it in and for some reason it's not working, check to make sure that your port has been set to the Arduino port. And if that moved for some reason, so like on a laptop, when you're plugging in and out, sometimes COM ports move. Be aware if it's worked in the past and doesn't work for some reason, inside of your IDE for Arduino, check to make sure that the port is correct. All right. It goes into here talking about how you can check all these things and the drivers. You don't have to install any of the drivers if the install occurs correctly. You just install it and away you go. I literally just ran the installer and it works. So, and I've done that on 4 PCs now and had no issues. Knock on wood, it'll blow up next time I do it. So the next item I want to go through after I close the wrong page. Nope, that's it. Is adding libraries, because in these kits, and sometimes you want to add a library that doesn't already exist on your inside of your IDE environment. So there's a couple ways to do this. One is from a zip file. So if I go in here and I go to Sketch and I go include library and I can go to add zip library. At this point, and by the way, I'm going to load on this PC downloads in the Elegoo, okay, English. There's a special, under module learning, there's a passive buzzer, and that buzzer has a special library for it in order for the buzzer to work correctly. The other one I did find that I believe it was the stepper, was it the real-time clock module, or one of these other ones had there it is. The real-time clock module also has a zip library that you'll need to add before you do labs with it. I'm just going to do as my example the same one they do, which is the buzzer. Click OK, click Open, and you will see library added to your libraries. Check Include Library menu. So now if I go back to Sketch, go to Include Library, I should see down here the buzzers are pitches. So pitches has been added in here. Stepper was added in earlier, so pitches is in. Another way you can add libraries is to actually go into Manage Libraries, and it will show you those that are available. So for instance, I believe the one they want us to load as an example here is the not the loop function. Hold on a second. Find the one they want me to do. Can't remember which one it was. It doesn't matter. We can just pick one. So we can go ahead and look, and we can do I think maybe in sounds, but there's all kind of ones in here. So we can go ahead and look and find, let's just do sounds, type sounds. So we can't find it. Okay, so there's different Arcadia Labs. For this is for gameplay. All you'd have to do if you wanted to load this is click install, and it will add that library into your manager. So be aware, that's 2 different ways you can add a library, if you do with a zip file or by just loading it from the existing Arduino library manager. Questions about those 2 items. If the lab in the kit requires it, it will walk you through the process of doing it so that you will know that you need to do that. Okay. Now what I want to do is make this a little bigger, and I want to show you the hello world for Arduino. On the Arduino is this little built-in LED that can be set up to be actually turned on as a pin, or appear to be a pin. And we're going to load a sketch. And again, that sketch is just a basic C program that we're going to place into onto the Arduino and make it do what we want it to do. So we go in, and with the blink sketch, you will see one of the first things when we load it. And let me go ahead and load it for you. I'll just go ahead and load the blink. But you'll see File, and I'm going to go to Examples. And I'm going to go to Basics Blink. Okay, and it opens in another window over here. So you will see that here is our code. There's a bunch of, by the way, there's two different ways you can do comments inside of Blink sketches. One is to put a /* to begin a multi-line comment, and then a */ to end a multi-line comment. So everything inside of here, inside of those two, are comments. So I'm going to turn the LED on for 1 second, then turn it off. And then the other way is to do a // and that is a single line comment. So two different ways to do comments in your inside of the Arduino environment. Here we're going to set up. Basically, this says that we're going to do a single one-time setup of making the pin mode. The LED built-in will be the pin mode that we're going to be working on. In other words, it sets that particular LED to an output so that we can produce output with it or send output to it. We then have down here a void loop, which has this continually happen over and over again. Okay, so continually happening. And what it's going to do is it's going to write the built-in LED or LED to high. Wait a second, turn it off or set it to low. Wait a second, high, low, high, low, high, low. So when I upload this, now I'm going to switch my view. I'm going to stop sharing so that you can see the Arduino much better. But when I upload this, I just click the upload button, and I'll show you that's literally just the second button on the environment. You should see it blink a couple times to show the upload's taking place, and now you see my LED blinking. All right. So you've got a basic hello world. I now know that if I stop my screen sharing, oops, let me cancel that. All right. If I stop the screen sharing or start the screen sharing, you will see that I uploaded via the upload button here this small program that makes the LED blink and blink and blink. Now these examples are read-only, so if I want to change this, I have to go in and save this as my own program. And so here I'm just going to call it, they suggest my blink, so I'm going to call it my blink. I'll let you in a little secret I had. I was doing a network programmability lab with Python the other day. In fact, I've been troubleshooting it for weeks. And it was a NetMiko lab, and I named the Python script that I created, or Python program, NetMiko. Well, that was causing a problem because netmiko.py was already what was needed to import the NetMiko components. So I was getting recursive things. So just be aware, don't name it the same thing as what it's already named. Give it a different name. So I'm going to change this to 10,000. So it's not going to be a second. It's going to be more. And hold on 1 second, folks. I'm off Monday too. Okay. Sorry, folks. Somebody walked in, but I've now changed that. I'm going to save it. File, save. I'm going to upload it. And if it's correct, you should see a couple flashes here showing it being uploaded, which it is. And now you'll see that we stay on for much longer, blink off for a short amount of time, and then come back on. Boop. There we go. So it should be 10 seconds. I believe it's 10 seconds now, and then blinks. So we have uploaded, and we are successfully uploading programs to our Arduino. And I will tell you, embarrassingly, to my own embarrassment, one of the things that I forgot to do or did not know how to do when I was showing this at NCCIA conference is how to make it stop running the sketch. Well, there just so happens to be the basic sketch that is in the Arduino when you open it up If you upload that, it clears out the other sketch and it will quit blinking. It should just stay on at this point. So now it just stays on as the LED is on. So if you put this in, if you load one of the sketches and then you want to remove the sketch, you can always just take this base sketch. And in fact, I'm going to save this for myself and call it base. And then that way I've got a base sketch that I can upload to set it back to a base functionality. Are there any questions so far about what we've done here? By the way, it does show you what Arduino you're connected to in the bottom right-hand corner. So when I look here, it will tell me that Arduino Uno on COM3. And there are different versions of Arduinos. I believe there's this is the R3. There's an Arduino 2650, if I'm not mistaken, but there's several versions. I think they all basically run the same way. I don't have a ton of work with them, but from what I've seen. I love this as it walks you through the sketch and tells you what each set of the code is doing. So again, this is initializing. Tells the board we're going to use the LED pin as an output. So it sets that up. And then we've got a loop. It's mandatory for the sketch to have a loop. So that loop will go in now and do our writes of high and low voltage applied to the LED so that we get it on and off. It's basically on and off. Any questions on that? Jack, I think you said you've already played with this a good amount.
Yeah, I'm good.
Okay. Well, what I want to do with this now is let's see if we can make something work and just provide power to the LED from the Arduino. So what we're going to do is we're going to, if we zoom in here, okay, we've got a circuit. So we're going to have a 220 ohm resistor. We're going to take and apply 5 volts to the circuit. We're going to put an LED in the circuit so that we can power that circuit, and then we're going to connect it to a ground. So what we're doing here is we're actually just using the Arduino as a power source, and that's it. So I'm going to come over here. I've got to change. First, I've got to zoom out. So zoom out a good ways here. I'm going to stop my sharing. I'll zoom out and show you this cool little kit that comes with the Arduino. So here's the cool little pieces that come with it. I've got a multicolored LED there. We get a red one here. Oh, well, there it was. I'm gonna drop a red one. So I've got a red one. I've got a 220 ohm resistor. Don't think I have any of the other ones. I can get a 1K and a 10K here in a minute, but one of the things I do like about this system, if I can figure, the only thing I can figure out is exactly how to do my zooms and things yet. But if you're like me and can't see, that really helps to be able to see that resistor. Okay, so very nice there. But we're going to set up a basic circuit, and we're going to set it up so that we've got our breadboard. I got to get 2 wires here. Get red and a black. Really, any color work. Red and black. So let's get our. I'm just going to use the top 2 I got on my hand here. Use red and green, or white and green. All right. So one of the neat things about the breadboard, if you're not aware of it, I'm sure most of you are, but the breadboard has across the top and the bottom, it has areas where you can apply power down the entire rail. So these positive and negative rails are available for that. I'm going to go in here and find my ground, which I am blind, so I have to look in here and get it close to me. Not blind, but it definitely is not. I should have brought my glasses. All right, so let's see. Say 1, 2, 3. 1, 2, 3. So get the third one up. So let me see if I can't get this in here. Now, I will tell you, folks, again, if you've had a spinal cord injury, this is not easy. I had a doctor's appointment today, and he couldn't connect to my. I'll put this on the negative side, the ground. He couldn't connect to my, or I couldn't connect to my audio, so he was trying to. I was trying to tell him numbers and show him my hands, and we were struggling. Let's just put it that way. All right, so I'm gonna put this resistor in. It doesn't matter which way the resistor goes. I'll put that in 45. I said I would. And I'm gonna try, let's see, I believe the way this should work is if we can't get this. Oops, got that on the wrong side. That would have been bad. Actually, it wouldn't have been that bad, but so let's see if we can't put that in there. And this has to go to the ground. I might have to do some finagling here, folks. I need longer. Let me try this like this. We'll do that to there. I need longer LEDs. Oops. Again, this is flying without a net, folks, flying without a net. All right, so got that. And then now we're gonna do this to here to give us a resistor. I'll try to give us a resistor anyway. And then now we're gonna apply power and hope the whole thing doesn't blow up. If it does, y'all get to see me blow up a LED. And I may have the LED in backwards. That's always possible too. That's the only thing I have a hard time with this particular kit figuring out is which way the LED wants on these kits. Oh, we got her. We got light. We has light. And so what we basically have done at this point is we're just doing nothing more than providing off of the Arduino power and ground. We've completed the circuit. So we've got our ground, we've got power, we got a resistor. And then the lab consists of adding in different resistors. So with the 220 ohms should be fairly bright. If you swap it out for the 1K, will appear dimmer. 10K will be just about barely visible. So if I switch out the resistor, which I'm not going to do because you saw how much trouble I had doing it just to begin with. Actually, I will. Why not? It won't take a second. So let me grab a 1K resistor. They do have them nicely marked inside of the kit, so you don't have to struggle to read the resistors, which is very nice. I still drop things when I'm trying to do this, but see if I can find it. They're in here. Here's a 2K, a 10. And of course, I'm not able to find the 1Ks right now. So 10K. Yep, found one. All right, I got one. So let's see if we can make it a little dimmer. You saw how bright it was before. Let's see if we can't make it dimmer. So we'll put us a different one in here. And see if we can get a little dimmer light. And then now apply that. And it's hard to tell the difference. I'd say it's a little bit dimmer, but not much. Not much at all. So, but it is a little bit different. If we went even higher, then it would definitely become dimmer. So that is a basic LED on your Arduino. Now I know to you that's very simple, that's very basic, But for students who've never done much electronics, which I haven't done a lot of electronics, so just seeing things make blinky lights is very neat. It also, once we get further on and we start loading programs to control these circuits, it's where things really get interesting for your students. Okay. All right. So, questions about that one? I'm not going to spend the time to do this entire one right now, but I do want to show it to you. Inside of the next section is using the RGB light. And so the red, green, blue, it talks about how you can control the pulse width modulation so that you're able to change the amount of, it's not really current, but the amount when the write takes place, and using that to change the color on the LED. And so on this one, what we're doing, if you look, it's actually in some ways a simpler circuit. But you've got 3 220 resistors. Those resistors are placed on each of the legs, 3 of the legs of the RGB, and then you download into the Arduino, and I can show you the code. Let's see, where did I go? Who's analog or digital? I gotta find it. Actually, I got to go get it. It is out in this PC. Downloads. The Elegoo kit. English. Module learning LGB. There it is. So it's over here. So you can see that we take this code and we set up and define pins, red, green, and blue as output, and then did the high, low, low, and we define variables for each one of those values. And then during the loop, we are setting those values and changing the values. So this is a value 0. So at this point, if you use this, it would be a red LED, and then you can go in there and change it. And then you can actually, with this one, it starts red and then it changes colors using this program. So it changes from red to green to blue and fades between those using the code to control the Arduino. So it's a neat extension of what we've done with our code so far. And y'all should have told me I wasn't sharing my screen because I was sitting there talking about it. And here's the code. Sorry about that. So I opened it up inside my Elegoo, and it's right here. So this is exactly what they're having you do when you do it in the Arduino Red components in the lab. But in this case, we're not using the Arduino Red. We're just using our Arduino Uno. So again, so it starts out red, and then it slowly changes to green, to full green, and then slowly changes again to full blue. And then we'll loop this as part of the program. So again, showing people that we use IoT devices not just to throw little programs on them, but to do things in the real world to control circuits. This could very easily be causing a during a light show for Christmas. You do a Christmas light show to where you can have it changing colors on LED strings on your house. And so real world examples of what something that seems silly could be used for. Okay. Are there any questions about what I've gone over today? Showing this Arduino board, showing the Arduino setup. Questions about the class in terms of the connecting things and the fact I'm going to give you, I'm going to set up your connecting things due dates, so be aware of that. No questions. Everybody see all, know all, hear all, you see my junky office.
I'm pretty clear.
Okay. Well, sounds good, Derek. I appreciate it. How many labs did you get done on the Arduino?
I mean, I've just been kind of working through the just the one course.
Okay.
And just kind of knocking it out. So I've got 1 or 2 left in that course.
Okay.
And then jumping over to the next one.
Okay.
But I did the Arduino and then had it like, so I got the blinking light, and then, you know, just because I'm a programming guy, that's my forte. So I just went ahead and like, oh, we'll make it blink SOS like in the programming lab, like in the Raspberry Pi lab and that kind of thing.
That's cool.
You know, just
my biggest problem with SOS was figuring out the dots and dashes, and what I wanted to do. I was like, okay, now how do it's dash dot or it's dot dash dot. So trying to figure out the amount of time to do it and those types of things. Not being a programmer, it was not the easiest thing on the planet for me. So.
And then I sort of cheated a little bit with the Arduino one because I didn't bother breadboarding the whole thing. I just did I'm going to wrap this resistor around the leg and throw it in the...
That's fine. That's not a problem. Yeah, that's not a problem. You can do it that way and it works just as well. You can do it without a breadboard. You just have to be a little careful.
Yeah, I mean, I just wrapped the resistor around the positive leg of my LED and just stuck it straight in the socket in my Arduino.
That works too. Definitely. Okay. Well, I'm going to stop recording.